Hi friends, today we're going to be looking at the Unit R Day 4 notes. This is the factoring packet. We're looking at page 5. Page 5 talks about perfect cubes. After we check for the greatest common factor at GCF, and then we check for perfect squares, check to see if the end terms, the terms on the outsides, are perfect cubes. If they are, then what we can do is we can do a standardized approach to solving these. So for perfect cubes, what we want to do first is we set up a set of small parentheses and large parentheses. The small parentheses, what we really mean is for two terms or for a binomial. And then the large parentheses is for three terms or a trinomial. And what we're doing with this is we're basically setting it up so that we have some spots and places to fill in. The first thing we want to do is after we set that up, then the next thing we want to do is do the cubed root of 8x cubed, or in this example, the first term, and then also the cubed root of 27, or the last term. So the cubed root of that gives us 2x and 3, so that's what goes in those spots there. The next thing we want to do is we want to square your first and your last terms. After you square your first term, you will put the symbol or the result in the first slot of your trinomial. And then when you square the second or the last term of your binomial, you're going to put that in the last spot of your trinomial. So squaring 2x gives us 4x squared. Squaring 3 gives us 9. Notice I'm not looking at signs, just the numbers themselves. So no positives, no negatives, just looking at the numbers themselves. Then what you do to get your middle term is you multiply these two terms together, your first term and your second term. Multiply those together. Those give you your number, that number for the second term of your trinomial. You now have all the numbers of your trinomial. To get the signs correct, what you do is you look at the first sign of your original problem. That goes here in the binomial. So because this was a minus, then this is also a minus. And the last term, the next term, so the term that's right here, it's always the opposite of whatever that first term is. So if this is a minus, then this is a plus. Likewise, if this is a plus, this is a minus. Your last term is always positive no matter what, because of how multiplication works. You're going to end up with a positive number. Whew. So now that we've gone through when we've done this, what we're going to have is, for these perfect cubes, we're going to have a binomial and a trinomial. Let's do number 3 together. Number 3 is 64m cubed n to the 6th. So let's see, are these perfect cubes? Can I factor anything out? Always check a GCF first. 64m cubed? Nope. No GCF. Nothing in common with n to the 6th. That kind of looks weird. M cubed, that's a perfect cube. Yeah. 64 is a perfect cube. If I take the cubed root of 64, you get 4. You can also check this by using your calculator. So if you're unsure of a number or value, so what you want to do is make sure you grab your calculator, and you should always grab it before you start recording, not saying it during the video while you have to reach over out of frame so the students can't see you while you're trying to find your calculator. No, don't do that. That would be bad. So always have your calculator handy with you at all times. Whew. All right. So if I'm going to take the cubed root, I showed this to you earlier, but go to the math menu, and what we want to do is then scroll down or key down to this one here. You can also do the 5th as well. You just have to type in the number 3 first. So again, I'm double checking to see if the cubed root of 64 is in fact 4. It is. I've checked it. I feel confident. What about that n to the 6th? What's the cubed root of that? If I think about what number multiplied by itself 3 times, so again, multiply by itself and then multiply itself, it's going to give me n to the 6th. That's just going to be n squared. N squared times n squared times n squared is n to the 6th. So going through and working through this, I've got the cubed root of 64m cubed. That's what's going to go in this first one. So the cubed root of 64m cubed is going to be 4m. And then plus, I'll hold off on the plus sign. I'm just going to leave a space there for now. And then the cubed root of n to the 6th, I said earlier, is n squared. And then now I need to set up my larger set of parentheses. So to get these first and last terms, I need to square. If I square 4m, I get 16m squared. And if I square n squared, then I get n to the 4th. And then to get this middle term here, I multiply these two together, and that's 4mn squared. I did not leave myself enough room. I apologize. Should have thought this out. I'm sorry you have to watch me erase. It takes away valuable time. You could be spending doing other things. Alright, so now 4m n squared. There we go. Okay, so now in between these, my first sign is whatever the original sign was, so that's plus. The next one's always opposite of whatever my original sign was, and then this last one is always plus. There we go. That is number 3. The next one I want to do is number 9. Number 9 down here below, 3x cubed and then 81y to the 6th. All right, so there's kind of a red flag in here already. 3? 3 isn't a cubed root. Wait, 3 also goes into 81. So let's factor out a 3 first. So if I do that, I'm left with x cubed minus. Now, 81 divided by 3 should be 27. You know when you feel like, all right, just need to go with it. And then, oh wait, x cubed, that's a perfect cube. Negative 27, that is a perfect cube. Here's where students make mistakes. You lose the 3. You're like, the 3's gone. It magically disappeared. I factored it out. No, it's still there. It's still part of the problem. So when I do equals 3, don't forget the 3. And then I have x, and then the cubed root of 27 is also 3. Now to get my terms here in my parentheses, I'm going to end up with x squared 9. My middle term, 3x. Now my signs, my original sign here is negative, so that's a negative, positive, and positive. I'm now going to box this because this is quite different than what the other one was, and that is completely factored. Thank you for joining me on this video. I'll see you in the next one. Have a great day.